Hey guys, hope you're having a wonderful week. I'm Euphoraj and this is the first video in a new series where I delve into my workflow for rendering products designed in SolidWorks using Cinema 4D and Redshift. Today's video is all about preparing your SolidWorks file so it's fully ready to be imported into Cinema 4D. Let's get started. So guys, jumping into SolidWorks, here we have an assembly that I've made a while ago. Now this assembly has got a bunch of different parts and I'm going to talk you through a few different steps that I go through, a few checks. These are some checks I like to do before I take things into Cinema 4D. It makes life a whole lot easier. I'm going to break this down into 3 overall themes. The first is making sure that our geometry is all in order. The second is checking our assembly to make sure there's no issues with our assembly. And the third is just beautifying things a little bit, making our lives a little bit easier when we come to apply materials. So, making sure our geometry is all in order. What does that mean? Well, the first thing I like to do is make sure that I'm applying fillets deliberately. What that means is I'm leaving hard edges hard and rounding the corners that I want to be rounded with a fillet. Now I know a lot of people like to add small fillets on all edges regardless of whether they're meant to be filleted or not, and this gives the product a more lifelike appearance in the render, and this is true. However, most rendering engines allow some way to round hard edges at a global or material level, including Redshift. We're going to be using the renderer native rounding options to keep our geometry true to intention. To give you an example, I'm going to jump into the shell over here. And looking at the shell, you can see that I have added fillets. I've got fillets around the outside, over here, here, all around the edge. However, the corners that I want to remain hard, such as this headphone jack over here, the cutouts for the port, for the mounting screws, for the buttons, they're all hard edges. They haven't been filleted at all. If I zoom in, you'll see there's no fillet whatsoever. This is important because it reduces the polygon count of our model when we're importing into Cinema 4D. That being said, I have been sure to add fillets where I want them to be present. The obvious example are the rounded corners of the device over here, but it goes further than that. Even small fillets, like the rounding of the buttons here, these aren't going to look like hard edges in the product render. They will be rounded to a certain degree, albeit less than some of our larger fillets. I have gone and added these in to add control. Another side tip is if you want to include things like threads, absolutely do so. Now is the time to model things like threads in your parts. Just be aware that the more complexity you add to your models, the harder it will be on your computer. So make sure you've got the CPU and GPU to handle the extra geometry. In this model, I've gone ahead and modeled the threads on individual screws. I know it's kind of extra, but it gives me freedom to do stuff like exploded views later on in Cinema 4D if I want to. Second up, checking your assembly to keep it nice and organized. My tips here include using patterns as much as possible. Now here, the only thing that I really could have patterned is this second screw. I have done that. I've used a mirror, but definitely make extensive use of these options over here. We've got linear, circular, we've got sketch-driven patterns. I'm not going to jump into how to do this stuff. There are people far more qualified than I am at explaining these particular tools. However, I will say this, use these patterns wherever possible. Makes things a lot easier to deal with in your feature tree and also from a geometry standpoint. If you can't use a pattern, at least reuse parts wherever you can. I have used a pattern for the second screw, but if I didn't and I wanted to add a second screw, I would still be best off inserting another instance of that same part file rather than modeling a second screw with all new geometry, even if it's identical. Cinema 4D is smart enough to recognize these patterns and reused part files, and it converts these to matrix instances which don't use anywhere near as much video memory in the Redshift engine. Second of all, if you have a complex assembly, make sure it's laid out using sub-assemblies. This is more for personal preference, but I find it helpful in keeping the model tree organized and easy to understand. And the most important thing with assemblies is to check your parts for interference. Interference is when two parts are inside each other, occupying the same physical space. It's not possible in the real world, and we aim to keep it that way in the digital world. The reason for this is because two coincident polygons or faces create a confusing surface for the Redshift engine to work with, especially if they've got different materials applied. As a rule of thumb, I try to aim for at least 1/100th of a millimeter interference gap between parts, although this is usually closer to 5/100ths. Keep in mind, this is for the small models. Larger scale models might work fine with larger interference tolerances. In this model, most things are tolerant to within 5/100ths of a millimeter, sometimes going down to 2/100ths of a millimeter, but never really less than that. Number 4 is just making sure that your mates are applied and you've configured an exploded view if you want one. For this tutorial, I'll be sticking to an assembled view, but if you want to configure an exploded view, there are plenty of tutorials that you can refer to. I've linked some down below. And the third theme is making sure that everything's beautified and making sure that my materials are applied. Now, the first reason for doing this is because it generally looks nice, especially if you've got real view graphics enabled. You see nice reflections on bits that are meant to be shiny. However, more importantly, it helps us identify different materials in Cinema 4D, speeding up the material application process. I've applied this technique to my model by applying materials wherever necessary. I've got gold contacts inside the headphone jack here. This is made of plastic. I've applied an aluminium appearance to the outer shell with a sort of plastic antenna band. And I made sure to apply a shiny polished aluminium appearance to all of the bits that are shiny and polished, such as the outside bevel of the charging port. Once you've checked your assembly for all of these, you're pretty much good to take your assembly straight into Cinema 4D, and I'll show you how to configure the tessellation settings. Okay, so in Cinema 4D, it's as simple as dragging our SolidWorks assembly into our file, and we're greeted with this lovely window over here, SolidWorks Import Settings. Now, there's a couple of things that we want to change from the default settings, the first of them being in materials. So let's go to materials, click the drop down and select based on display colors. This will let us retain the separation that applying different materials to different parts of our geometry in SolidWorks did for us. Next, come into tessellation, and rather than sticking with original, we're going to go under high and then tweak these settings just a bit further. Now, these will depend on the capabilities of your computer and also the size and the finesse of your model. I know that I'm working with really small details here, such as the threads on my screw. I know that some of them are less than 1/100th of a millimeter in size. So I want to come down into the maximum sag and change this to 1/100th of a millimeter. I'm going to come to the maximum angle here and change this. Now, this will again depend massively on how much system memory you have, and also when you come to rendering in Redshift, how much video memory you have. So tweak these values with a bit of trial and error. If you experience lag or crashes, increase this number so that you aren't dealing with such a high number of polygons, but just know that you will have a less detailed model. I know that my workstation can handle 1 degree, so I'm going to set it to exactly that. Next is max length, and this is more useful if you're working with models where polygon size might vary considerably. However, I'm going to leave it at 0 for now. You can always fix polygon inconsistencies by using the new Z remesher in Cinema 4D. Then we just click OK, give the computer a second to load our model, and voila, here it is. We can move around our model, we can explore all of the geometry. Here's a quick tip. If you're experiencing clipping artifacts like this in Cinema 4D, hit Ctrl D to come into your project settings. Under project, you want to navigate to display, come to view clipping, and set this to tiny. Tiny will allow you to zoom in closer to objects. However, you will lose some range for larger scenes. The opposite is true for larger values of view clipping, and you can always customize this using custom as well. I'm going to set it at tiny because we have a pretty small model here and I want to get really up close to certain detailed aspects like this screw, for example. Coming into our model, we can see that the details have come out quite nice. The fillets have come out very accurate. The screws aren't missing any faces or any such geometry. And if we want to see all the polygons, of which there are a lot, be warned, we can come into display and select any of the options that have lines on them, and we'll see a metric buttload of lines appear. These are all the individual polygons that make up our model. That's a bit scary for me, so I'm just going to go back into normal shading. One error you might encounter when dragging your SolidWorks file into Cinema 4D is Cinema 4D telling you that it's an unknown file format or it doesn't know what to do with the SolidWorks file. A nice workaround I've found for this problem is to go to your SolidWorks file and just rename it so that the extension is all in lowercase. In this case, I'm going to rename it to SLDASM, but all in lowercase. and this seems to fix the problem. In the next video, I'll cover applying materials to your model and how we can round corners like we said at the start of this video. Thank you so much for watching. If you enjoyed this video or found it in any way helpful, I'd appreciate it if you drop a like below. If you're a designer looking to pick up more quick tips and tricks, especially relating to rendering, get subscribed, as I'll be dropping more videos not just sharing my workflow, but also checking out some really cool rendering tools. That's all for today, and I'll catch you in the next one.